Okay, number 3 really is a binomial one. It shouldn't really be in this, but we'll just go with it anyway. So x is distributed binomially, and it is done 8 times, and success is getting a 3, where p equals a score of 3. So part 1, find probability that the score of 3 occurs exactly 4 times. So let me write out the formula first. NCX, PX, Q, M minus X. So probability X equals 4 is 8C 4, P to the 4, and Q is 1 minus the P, so it's 27 40. To the, 8 minus 4 is also 4. And if you plug that in, that's the figure you get out. Part 2. You want the score occurs at most 2 times. So probability of x less than or equal to 2. So we want score of 0, score of 1, score of 2. So it's 8C0, P to the 0, Q to the n minus 0, plus 8C1, P to the 1, Q to the n minus 1. And again for the last one, 8C2, P to the 2, Q to the n minus x. Working all of those out, you should get 0.0431 plus 0.166 plus 0.2797, giving you an answer of 0.489 when you round that. Expected score isn't something you need to know, but I'll just pop it in anyway just for completeness sake. It's just n times p, so 8 times 13 over 40, which is 2.6. And the variance again is not something you need at the minute, but let's pop it in, NPQ, so it's 8 times 13 over 40 times 27 over 40 to give you an answer of 1.76. We're also going to look at question 6, which is a better question out of this paper. So they are exhaustive. So that means there's nothing outside A or B. So I could write down A or B is 1. If you look at it in a wee picture, it can help. So that's A and that's B. There's nothing in the outside bit. The probability of B, this whole circle, is 0.72. The probability of B given A. Now before I go any further, I'm going to think of the formula. So A and B is the probability of A times the probability of B given A. So you're looking for the probability of A. I'm going to try and use all these wee bits and pieces here to try to work this out. I know probability of B given A is 0.3, so there's one formula. The formula for A or B is the probability of A plus the probability of B minus the probability of A and B. So 1 equals probability of A that I don't know, probability of B I do know, probability of A and B I do know. Okay, so just jiggling this around a wee bit. 1 minus 0.72 is 0.28, and that's one probability. Take away 0.3, so it's 0.7. Bring that across and divide. So the probability of A is 0.4. And part B from this year. If I glance down to the bottom, it says a child chooses both tennis and football is X. So I'm just going to think of it as a wee picture. Tennis, football, and X. Okay. Right, the probability a child chooses football but not tennis is 2/5. The probability a child chooses tennis but not football is 2/15. They are independent, so one doesn't depend on the other. So if they're independent, let's try and remember what that means. So the probability of tea and football is the same as tennis and football. You don't have to worry about the given thing in this. Now, we want tennis and football from our picture is x. Tennis, complete from our picture, is 2/15 plus x. Football from our picture is 2/5 add x. So I've got an equation I can work with. I'm just going to expand it out here. So I have 4/75 plus 2x/15 plus 2x/5 plus x squared. I'm going to multiply everything by 75, just get rid of that fraction. So 2 divided by 15 times 75 gives me 10x. Just timesing right across by 75 the whole way. So it's going to be a quadratic. So putting everything on one side, 75x squared, 30x minus 75x is minus 35x. And I've got a plus 4. Now it's probably just quicker just to use the formula in here. So just remind you, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is minus b, so minus 35 over b squared, always make sure it's a positive number because if you square a number it's always positive, minus 4 times a, which is 75, times c, which is 4, all over 2a. So I've got x equals 35 plus or minus the square root of 25 over 150.